This video is part of a series. It's heavy in scientific terminology and may expect familiarity with previous videos. If you're confused, please watch the rest of the playlist up until this point, or check out my genetics terminology document, both of which are linked in the description. Thanks! We're starting off easy with the L Locus, which determines if a cat is long hair or short hair. This is a simple monogenetic trait with two alleles and complete dominance. Sort of. Short hair is dominant, represented by capital L. Long hair is recessive, represented by little l. Or at least, that's the simplest model, and also the only one you need to worry about. Some studies have found multiple alleles that cause long hair, but they all seem to be on the L locus, also known as FGF5, and most of them are specific to certain always long hair breeds. They all look more or less identical, and I don't see any evidence of them inheriting differently, so for all artistic intents and purposes, just lump them together as little l. As a reminder, epistasis is when one gene prevents a totally different gene on a different locus from expressing. All of the bald-type genes you're going to see are epistatic to long and short hair because, the cat doesn't have any hair, so it can't be long or short. Got it? Cool. Let's get to the weird stuff. After a quick primer, cats have three types of hair. Guard hair, which is the top layer, as well as the longest and the most coarse, for protecting the body and other hairs from things like water and sunlight. On hairs in the middle, which are for insulation, they keep the cat warm. And down hair, aka the undercoat, the smallest and softest hairs, which are also for insulation. All of these hairs grow out of follicles in the skin. Mutations that make cats' fur look weird are the result of messing with one or more of these layers or with the follicles themselves. Also, mutations and phenotypes responsible for weird hairs tend to be named after the breeds that have them. Know that when I say a word like Sphynx or Cornish Rex, I'm talking about the mutations and phenotypes, not the breeds, unless I specifically state otherwise. Just like in the video where I talked about color points, there's a lot more that goes into a breed than a single phenotype. Sphynx is a hairless phenotype. A mutation in the KRT71 gene region prevents a protein from helping form part of the cat's hair follicles. Hair itself forms normally, but falls out, so the cat is essentially hairless, although they do have very, very thin coats that are more visible in some than others. Since pigment-producing melanocytes are found in the skin, Sphynx cats will still show their underlying pigmentation. Calico Sphynxes especially look really cool. Unfortunately, Sphynx cats don't have whiskers, which is not great ethically. Whiskers are an important sixth sense that help cats navigate their environments. Not having them is a huge problem. Devon Rex is one of the many curly hair phenotypes found in cats, and they get their appearance from having little to no guard hairs. They have this downy ruffled appearance, like a Shar-Pei dog with fur instead of skin, and it's a little more prominent and fuzzy in long hairs. They have whiskers, but they're short, fragile, and tend to break easily. Ouch. As for inheritance, the normal for regular cat allele is N for normal. It's completely dominant over both Sphynx and Devon Rex. Sphynx is represented by HR, fully recessive to N, and fully dominant over Devon Rex. I've seen two different alleles for Devon Rex, DR for Devon Rex, and RE for Rex. I'm going to go with RE because I've seen it more frequently, and of course it's fully recessive to both N and HR. The breed Peterbald came from crossing Donskoy cats to Oriental Shorthairs, so if you're looking for Peterbald-type hair, this is your section. It's the same genes. Donskoy can look just like the Sphynxes we've already covered, but are caused by a totally unrelated gene, or rather a set of genes, because Donskoy is a complex, albeit with only one single known modifier locus. The light switch gene is HRBD, short for hairbald, which I'm going to call it, and it seems to be incompletely dominant. Confusingly, it seems like breeders use HR for normal hair, which are the same letters used to represent Sphynx hairlessness. Again, the letters we use to represent alleles are largely arbitrary. To avoid confusion just for this video, I'm going to stick to using N for normal hair. Its modifier locus has two alleles, Hi and Ha, which are incompletely dominant with each other, and for funsies I'm going to pronounce them like the words instead of saying both letters every time. Hi increases the amount of hair and Ha reduces it. Any heterozygous hairbald N cat is going to have what's called a brush coat, regardless of their modifier alleles. Brush coats are only about 5 millimeters long, wiry or curly, and tend to feel like felt to the touch. Their whiskers are curly or kinky. Hi homozygotes have normal brush coats. Hi-ha heterozygotes have brush coats, but with some bald areas. Ha-ha homozygotes are born with brush coats, but turn bald as they grow up. As for homozygous hairbald cats, homozygous high will result in a velar coat, 70% bald, and what fur they have is only about 1 millimeter long. Cats with velar coats may lose their hair and become bald by about 2 years old. I wasn't able to find any whisker data for velour. Heterozygous high will result in a flocked coat, 90% hairless and feeling like chamois leather to the touch. Really? That's how that's pronounced? Sometimes they have a bald spot on the top of their head, and their whiskers are kinky, curly, or broken. And finally, homozygous ha results in rubber bald, wherein the cat is fully hairless and also kinda sticky. They don't have whiskers. They also have an insanely high infant mortality rate, as apparently fading kitten syndrome is incredibly common, at least in Peterbald breed rubber bald kittens. There's also some concern that hairbald homozygosity can cause bad teeth dentition and an inability to produce milk in females. Like the Sphynx, bald Donskoy cats still show their underlying pigmentation. Selkirk is also a mutation in the KRT71 region, but it's further downstream than Sphynx and Devon Rex, so it has its own locus. They're curly-haired cats with curly whiskers, and they look like they just came out of the clothes dryer. The curls are most prominent on their sides and the neck, and the least prominent along their back. Long hairs tend to be a little puffier than short hairs. The cause of Selkirk's appearance is that the allele affects the keratinization of the hair follicle, affecting formation and maintenance of hairs. Once again, the allele for normal hair is N, and the Selkirk allele is SLK. Most sources say SLK is completely dominant, while one source says it is incompletely dominant, where homozygotes have tight curls and heterozygotes are more wavy. My source for incomplete dominance is a veterinary genetics lab that offers public gene testing and has so far had very reliable information on other loci, but the same page that describes Selkirk as incompletely dominant also describes the heterozygote phenotype as having smaller ears and a particular body type, and I haven't found any sources backing up that a keratin mutation can have that kind of pleiotropy, so I'm not sure what's going on here. However, the Cat Fanciers Association doesn't distinguish between homo and heterozygous individuals, nor between tight curls and waviness, and they refer to Selkirk as completely dominant. I'm more inclined to believe this model. So as a writer or an artist, if incomplete dominance seems like it'd be more fun, go for it. I would just keep it to tight curls versus waves, though. But, going for pure realism, it seems like Selkirk is completely dominant. For now. While the Devon Rex has very few guard hairs, the Cornish Rex phenotype has no guard hairs whatsoever, leaving the cat super soft and, of course, curly. The lack of guard hairs also mean they have oilier coats and need more frequent bathing. Normal hair continues to be N, and Cornish Rex is represented by CR. I've also seen little r used. Regardless of what letter you use, N is fully dominant over Cornish Rex, which is, of course, recessive. There's a breed of cat that has the Cornish Rex phenotype, known as the German Rex, which confuses some people into thinking that German Rexes are a separate phenotype caused by a different gene. It's not. German Rexes are Cornish Rexes. I mean, the breed is different, but the gene behind the hair texture is the same. LaPerm causes a type of curly coat that can reportedly range from tight ringlets to long corkscrews. Some of this variation may be due to the age of the cat, or the current season, or it may be the result of polygenes. Probably both. The tightest curls are found at the cat's underbelly, throat, and behind their ears. The hair reportedly isn't silky at all, but it is very soft, light, and airy. The whiskers are curled, as is the hair inside the ear. Sometimes there's a natural parting down the spine. Short hair LaPerms have more texture and tails that represent bottle brushes. Long hairs, however, have plumy tails. I was unable to find the mechanics behind why the hair is like this, sadly. LaPerm seems to be completely dominant. For once, none of my sources are using N for normal hair. Instead, capital LP is responsible for LaPerm, and little lp is responsible for normal hair. But these letters are largely arbitrary, so you can still use N if you want. Oh boy. The Lykoi gene is also known as the werewolf cat gene. This messy, semi-bald appearance is due to less hair follicles and smaller pores, which also causes severe lymphocytic folliculitis, which is a type of painful, itchy infection, as well as possibly cysts. These start to appear when the cat is about 3 to 5 years old and last for the rest of their lives. At some point, Lykoi cats fully molt, leaving them totally bald and then growing their hair back. This molting seems to not be harmful, but the Lykoi gene and breed are both disgustingly understudied, and it was beyond irresponsible for the breed's founders and official cat breed organizations to rush into accepting it and selling this breed as fast as they did, with as little research as they did. It takes decades to investigate a gene for new health complications. Don't trust websites that tell you this phenotype is healthy. Skin conditions don't show up until the cat is already 3 to 5 years old, so a lot of those articles were written before owners knew or by people who still don't know, and Lykoi owners tend to keep discussion of their cat's health to private groups. Unfortunately, this gene is pleiotropic. It fundamentally causes both of these effects. There isn't a way to breed out painful skin conditions without also breeding out the werewolf look. It's just not possible. Reducing skin conditions also means reducing werewolfiness. They're the same gene. The same gene also seems to cause roaning, with some hairs not having any pigmentation that just leads to this kind of grizzled ticking look. As for that gene, it's recessive, although it's worth noting that the mutation responsible for Lykoi has mutated several times independently in different parts of the world, meaning there's actually several alleles that could be responsible for Lykoi. I'm not sure which one is being referred to in articles that call Lykoi recessive. I'm going to treat it like long hair, wherein there's a lot of different alleles that all inherit the same way and ultimately do the same thing, and just pretend there's only 2 alleles. That being said, I'm not sure what symbols to use. Messy Beast lists all named Lykoi alleles as HRTN, HRVA, HRTX, HRFR, HRNC, and HRCA, and I don't know which is the main one being used for the breed, so make your own symbol, I guess. It's recessive. Let's just say it's recessive to normal hair N and call it there. I'm not going to give any practice Punnett squares for the simpler loci. You should understand basic dominance and recessives by now. We'll do one for Sphynx Devon Rex, and then we'll do one for Donskoy. Starting with the Sphynx Devon Rex, tell me the parents' phenotypes, solve the square, and then tell me the percent chances for each potential kitten phenotype. Here we have a normal-haired parent and a Sphynx parent, both carrying Devon Rex. They have a 50% chance of a normal-haired kitten, a 25% chance of a Sphynx, and a 25% chance of a Devon Rex. Now for the Donskoy. Those who watched the multi-locus Punnett square section of the Concepts and Terminology video, if you're up for it, try to draw a Punnett square for both Donskoy itself and its modifier. For everyone else, this Punnett square is just for the modifier locus. Pretend both parents are homozygous hairbald, and thus all their kittens will also be homozygous hairbald. Both parents have a flocked coat. Their kitten has a 50% chance of being flocked as well. There's also a 25% chance of a velar coat, slightly more hair, and 25% chance of being totally rubberbald. I'd say I'm sorry for being such a downer in this episode, but I'm not. Knowledge is important, even the sad ugly stuff. Being educated about the subject you study is more important than blissfully ignoring all of its problems. And the next episode's gonna be worse!